So good morning. My name's David Wheeler. I work, as he mentioned, at the Institute for Defense Analyses. I'm very interested in defending software against attack. I also support the Linux Foundation, which is primarily what I'm going to be talking about today. So I'm going to be talking about the Linux Foundation's CII, or Core Infrastructure Initiative, Best Practices Badge. I'm the technical lead of the project. And my hope is that I will inspire many of you to either work on your projects getting a badge or encourage the projects that you're involved with getting a badge. So let me explain a little bit about that. First, I'm going to very, very briefly give some background that may help, especially those who aren't familiar with the Linux Foundation. So first of all, I hope that all of you will understand, I have to deal with people from very, very different backgrounds who have very different preconceptions about open source software, which are often mistaken. It is absolutely not the case that all open source software is insecure. I meet those kinds of people, particularly if they're from companies that are selling competing products. However, it's also not true that all open source software is secure. Just like all of the software, some open source software is relatively secure and some is not. This was particularly brought out to bear in 2014 with the Heartbleed vulnerability in Openssl. And this really demonstrated to a lot of people what really was already the case, that there was some widely used open source software that nevertheless really needed some kind of investment for security. And so the Linux Foundation created an organization inside it called the Core Infrastructure Initiative. And the mission it's to fund and support critical elements of the Global Infrastructure Initiative. So here's a little more about the CII, just briefly. It's a multi-million-dollar project supported by many, many companies. You would recognize a lot of these names, I'm sure. And it fundamentally can be talked about in terms of three actions. It collaboratively identifies and funds open source software projects in need of assistance. It allows developers to continue their work. It is not the goal of the CII to take over projects. It is the goal to help projects do a better job of what they're already doing. And finally, the CII is transitioning from point fixes to holistic solutions. This does not mean the CII is not interested in helping specific projects. They still are. However, there are so many projects out there, open source software projects, that someone depends on, that it is difficult to fund every single project that someone thinks is important. So instead, the CII funds a few that are very important, that are widely used, and also funds some activities that can help sort of raise all boats, as it were. Here are some investments in some of the key open source software projects. The graph on the left, for example, shows Openssl. The Linux Foundation CII funded Openssl, including some key developers, focusing on things like improving security. The graph here shows the number of issues. Up until 2014, there were more and more issues being requested, more tickets, but no one actually responding to them. And suddenly, as of 2014, a huge number of tickets were resolved one way or the other. And they're working with other projects, including, for example, auditing the code and so on. The CII also funds projects that have multi-project impacts. For example, it funds an organization called the Fuzzing Project, which uses tools called fuzzers that send random data into programs, but a very large amount of it, looking to trigger vulnerabilities of different kinds. This has found a number of vulnerabilities that have since been fixed by the various open source software projects. I led development of something called the CII Census. This was some quantitative work to analyze many different open source projects to try to identify which projects are particularly in trouble, higher risk, and nevertheless widely used and perhaps most in need of funding. And finally, the focus today is the Best Practices Badge. Okay. All right, so open source software, I think we'll be unsurprised to know, tends to be more secure if it follows generally good security practices, undergoes peer reviews. But how can we encourage those good practices? In fact, how do we know what those are? And never mind, how can we know if they're being followed? So we developed a simple approach. First, we tried to identify a set of best practices for open source software projects. And here I'm focusing on production side. In other words, what are best practices for open source projects that are developing software, not the reception side, what are the best practices for examining software you might bring in. And this was based very much on existing materials, existing practices already used by various projects. Once we identified criteria, we created a simple web application where open source software projects can self-certify. And if an open source software project meets those criteria, they get a badge. And the advantage of self-certification is that it scales. Now, there are problems with self-certification that I think many of you are aware of, and so we've worked to counter those. For example, there's automation that goes out and looks at the project, and for example, if we can determine, well, you may say that this is true, but it's not. We don't care what the human says. You have to actually make that true. We also require public display of the answers. That enables criticism, whether or not those are actually true. Whenever you create some sort of criteria, you need to come up with some sort of grading criteria, some scoring system. Here's the scoring system that we use. We have 3 different kinds of criteria: must, should, and suggested. Most of them are must or must not criteria, and they must be met. Should criteria can be met or possibly unmet with justifications, and suggested they can be met or unmet. At that point, we are fundamentally depending on psychology because most people don't like admitting when they don't do something that they admit they should be doing. I believe this is actually effective. In some cases, we do require a URL in the justification to point to specific evidence. Currently, we only have 1 level. We do eventually hope to have multiple levels of badges, but right now we're working just on a basic level, what we're called passing level, that attempts to capture what well-run projects typically already do. And this is important to understand. The level that we're focusing on is what do most projects currently do for each of those criteria, not what should they do, but no one actually does that. We're not interested in those criteria, some sort of magical ideal. We're interested in what projects actually demonstrate is a doable thing. And we intend to update these criteria annually. Whenever you talk about criteria, it's probably useful to show some examples. What do these criteria look like? Here's just a few. Hopefully we'll give you a flavor of what this looks like. Basics, for example, the software must be released as flawless. These are criteria for open source software. It makes no sense if it's not actually open source software. We suggest that it be licensed under the OSI. There are some reasons some projects simply cannot change their licenses or choose a very unusual license. However, we do suggest, we believe that there are advantages to using an OSI approved license. Change control. The project must have a version control source repository. If you don't use software to control your software, your versions, your project's in a lot of trouble, frankly. It's very difficult for people to track, to determine what's going on. And therefore, that isn't a must. Under reporting, one of the musts is you must tell people how to report vulnerabilities. This turns out to be a problem for a surprisingly large number of projects. Many projects have only public ways of reporting vulnerabilities. But when of reporting problems of any kind, if I find a vulnerability in your software, should I report it that way? It's okay if you do, but you need to make it clear. Most projects choose to have private reporting of vulnerabilities. I personally prefer that myself. But regardless of that, please make it clear what you want people to do. Otherwise, when a vulnerability is found, there needs to be first this discussion about how to report a vulnerability. That's the wrong time to have that discussion. The project needs to determine ahead of time how to handle vulnerability reports. Unsurprisingly, we wish to have projects with quality. Projects with poor quality are unlikely to have good security. So if the project requires building for use, there must be a working build system. You can't possibly test it or use it or make improvements to it easily without that. It must have at least one automated test suite. If you don't have an automated test suite, again, you are unlikely to produce quality product. You are unlikely to be able to make significant changes because you won't know if those changes broke your software. Must have a general policy that as you improve it, you'll add tests. We actually don't have a coverage requirement, how much testing is good enough. That turns out to be difficult to answer. We can talk later about, for example, the Linux kernel folks have difficulty because many people do not have the hardware needed to test the software. Okay, but you can certainly at least strive to do better. As you improve your software, make your test software better. There must be some warning flags to warn you of common problems. Since this badge criteria were originally created with the notion of being concerned about security, there are security criteria. We want to make sure that at least one of the primary developers knows of the common kinds of errors that lead to vulnerabilities. The vast majority of security vulnerabilities are in a relatively small group of common mistakes. Buffer overflows, SQL injections, cross-site scripting. These names, if you don't know what they are and you're a developer, please start learning them and what they are and how to prevent those kinds of attacks. Depending on your measures, easily over 90%, 95% of vulnerabilities tend to fit in a relatively small number of categories which have known countermeasures. But it doesn't matter if the world knows them if the developers on your project don't know what they are. The project's cryptographic software must use cryptographic protocols and algorithms that are public. If they are not public, they're unlikely to be any good today. And there must not be unpatched vulnerabilities. If you are releasing software and no one is fixing known vulnerabilities, there's a serious problem that needs to change. And the software needs to be analyzed. For example, require at least one, what's called a static code analyzer, at least one of those being used. The badging project has actually not been generally available very long. The general availability was announced in May 2016, so this is only a few months ago. And yet, as of now, this is a week ago, we have over 280 project entries, and this continues to grow. 35 are passing, and 63 and 90%. And here are some of the current badge holders. The web application we call the badge app, and you'll be glad to know that we ourselves receive our own badge. I think it would be terribly hypocritical if we couldn't achieve our own badge for our own criteria. Node.js, the Linux kernel, curl. I noticed that you mentioned GitLab a moment ago. They've got a badge. Openssl. Now, they currently have a badge. One of the project members actually went back to determine how well they would have done just before Heartbleed. It turns out to be difficult to figure out answers for historical questions, even though they were only 2 years ago. Nevertheless, they did the best they could, and they believed that before Heartbleed, they were missing about a third of these criteria. And so, although we did not develop it specifically with Openssl in mind, I find that encouraging that had this badging project existed at the time, it would have been dreadfully apparent that there were some very serious problems in the project. So, there have been, even though it's only been out for a few months, we've had some wonderful impacts already. OWASP Zap is a web application scanner that's a software program that pretends it's a web browser and basically clicks on websites and sends it garbage and tries to break your web application before users do. It's a very, very widely used test program, and its leader is actually at Mozilla. Sam Bennett basically said, hey, this badging process really helped us improve Zap quality, and in particular, it gave them the impetus to significantly improve their automated testing of their software. They had known this was a problem, but this gave them the impetus to actually go fix this long-standing problem. Common Mark, which is implementation of the Markdown text processing in PHP, made some changes as well. For example, they changed to using HTTPS for their website and links from the repository to it. And they also published their process for reporting vulnerabilities. These turn out to be very common problems. A lot of open source projects either don't use HTTPS, don't have any way of reporting vulnerabilities. But since these are requirements under the badging project, very quickly oh, wait a minute, these are things, and generally we have not had pushback saying, no, these are bad ideas. Generally people agree, that is a good idea, we should do that, and have been willing to actually make changes. OPNFV changed some cryptography algorithms. They were using ones that were known to be broken, and when they wanted to get a badge, oh, we need to stop doing that. These are no longer acceptable today. Another one, Jason for Modern C++. I have very nice comments. One particular I found very comforting. He appreciates some formalized quality assurance, which even hobby projects can follow. We design these criteria to work with small projects, with big projects. It works with the Linux kernel, very large project. Works with curl, fundamentally a one-person project. But yet, no matter what the size of the project, these are criteria that make sense. Version control, tell me how to report vulnerabilities. And again, made some changes to improve the software. I'm glad to say that the badges are getting adopted. This is the set of graphs from a week ago. So you can see the number of projects slowly increases. The number of projects that either have a badge or have made various, they're smaller. Many projects have just started. I just checked this morning and I found that wget just started the process 2 days ago. A lot of folks use curl and wget. Curl's already got a badge. Wget just started. And basically quite a bit of activity. And so even though we have just started recently, I think we've gotten quite a bit of acceptance already in the community. I thought it should be fair that if we're concerned about security, well, what about you? Well, I'm sorry to say that we can't guarantee security, but we can do things that increase the security of our own software. And I point this up in part just to give an example that, yes, an open source project can take steps to increase its security. Does it guarantee absolutely no vulnerabilities of any kind? Do I guarantee there are no mistakes? Nonsense. But there are things we can do. And just as an example, we actually describe ourselves how we secure our web application. We tell people how to report vulnerabilities. We have very, very simple requirements, and we've intentionally designed it to, for example, if we don't need the data, we don't record it. It's hard to lose data you don't have. Our design, we applied various design principles. We have very simple applications. Verification, we use a number of different analyzers to look for vulnerabilities. We consider software before we use, and we also constantly check to make sure that the software we use itself doesn't have known vulnerabilities. And if it does, and we've had several times where a vulnerability was found in some component we reuse, we immediately are told about it. We have an automated test suite, so we can just say, upgrade this version, rerun the tests, it's good, ship. Last time it took us less than an hour between the time it was reported to the time where the new version was in production. Why? Because we planned for that. Okay? And other projects can do the same. I'd like to talk a little bit about future criteria and future thoughts. And we certainly would love, your expertise. You represent a large number of different open source software projects. Involved in some way or another. We very much would love for you guys to work on getting badges, and we would love your feedback on how to improve this process. Some of the examples of future potential passing criteria include things like, we're at least mentioning hardening mechanisms in general and reproducible builds. And really, we'd like to add higher levels. We had originally planned to add higher levels sooner, but right now we're finding a lot of people are struggling even to get that first stage. Even if each of the criteria are common, that does not mean that the entire set is necessarily easy. Any one project may reach 80% or so, but that last few, I agree I should do that, but that will require a change of me. And right now we're finding a lot of projects in that situation where people generally agree, yes, those are good things to do. Yes, I know many projects do it, but here's one I don't do. I guess I better fix that. But some at higher levels, things like really an active development community is an excellent thing. something called a bus factor, i.e. if a bus hits someone, the project should be able to just keep going. Handling dependencies periodically, checking them, making it easy to update. Having someone else review all the changes. Automated test suites. These are the kinds of things that we would like to include at higher levels, and we would certainly love to receive your feedback and suggestions. So, if you lead an open source software project, what you do matters. It's important. One of the things that was remarkable about CII is that the CII was initiated with the idea of trying to fund specific projects. And as I said, it still does. But the remarkable thing they also found is that everybody has someone they depend on. And everyone has something that depends on them. No matter what, if you are supporting or involved in an open source software project, someone else is depending on you. Someone else is depending on you. And therefore, because people depend on the software you create, the practices you apply affect the results not just of your own project, but of other people who depend on you. Secure software, quality software, it's not an accident. I want to encourage you to try to strive, to improve, to try to develop more secure software, better software. And if you're considering using an open source software project, check on the project. Should you use that? And I believe that this badging process and badging criteria can help with this, because it's an attempt to capture in one place, here are criteria that appear to apply as best we can determine to all open source software projects, big, small. Okay? And therefore, I would encourage you, strive for that badge. Try. You can simply click on a get your badge now button and start that process. And if you find that there are problems because there are things you don't do and you should do, well, you now have more information than you did before. On the other hand, many well-run projects find that we're doing all those things. Well, frankly, that's encouraging. You get that badge, post it on there, and actually have some encouragement that, yes, there's always ways you can improve, but at least you're doing a lot of those basic fundamentals. Here are a few URLs. The CII, if you want to just find out about the CII in general, there's their URL. If you're interested in the best practices badge, and get a badge, bestpractices.coreinfrastructure.org. Basically, you can go there, you can click on get a badge, start filling information for your project, and find out how you're doing, and hopefully either get a badge, and it is perfectly fine to start and work at it over time. Now, remember those other graphs earlier, people are slowly, they'll start getting a badge and, we're not doing some of those things, and they'll go work those and come back and fill in more things later. If you wish to be involved in the Best Practices Badge project itself, you think our criteria should be different. You would like to contribute to improving either the current criteria at the passing level or those higher levels. We'd love to have your help. We'd love to have your contributions and your ideas. And if so, it's on GitHub, and there's the URL for that.